The Cambrian era took place roughly 544 to 505 million years ago, while Michigan was covered by one of the first of many oceanic episodes that occurred over the state during a period of a few hundred million years that formed the Michigan Basin. Here is a 3D representation of how the shape of the Michigan Basin influences how the Cambrian Age rock settled underneath Michigan. The bottom of the basin is deepest near the center of the mitten, with it gradually approaching the surface as we head north into the state. Cambrian-era rocks themselves are the oldest rocks found as a part of the Michigan Basin series, outcrops of which are present in a long strip that covered the middle of the upper peninsula of the state. Most of the Cambrian-era rock is composed of a series of sandstones, trailing from the Jacobsville sandstones of the Precambrian to the Munising group, which is composed of Mount Simon, Eau Claire, Dressbach, and Franconia sandstones. Most of the material for the sandstones found in this layer are a result of heavy erosion of regional hills and mountains, which eventually are washed by fluvial forces into the lowest part of the Michigan Basin, where they built up a thick, nearly 4,000-foot layer over about 40 million years. Compared to Precambrian rock, the sandstone in the Cambrian layers include a much higher abundance of carbonate lithology due to an event that separates the eras known as the Cambrian Explosion, which saw a flourishing of much of the early complex life on Earth. As mentioned, Cambrian rocks in Michigan are a majority sandstone with outcrops stretching across the upper peninsula. The lithologies present in the Cambrian layer are as follows: interbedded Precambrian layers of the Jacobsville sandstone, the Mount Simon sandstone, Eau Claire layer, the Dressbach sandstone, the Franconia sandstone, and at the top, as it transitions into the Ordovician rock, the Trompelow layer. Beginning at the bottom, the basal layer of the Cambrian series is the Jacobsville sandstone, which also underlays much of the Lake Superior region. While it is a pre-Cambrian layer, the top of it lenses into the Cambrian Munising layer, which can be seen at pictured rock. It is generally a dark red and brown arcosic sandstone with some strips of shale and has conglomeratic inclusions near the base. This sandstone once had a greater economic significance as a building resource, with some old local churches being built with rock from this series. All lithology following the Jacobsville sandstone is purely Cambrian in origin. The major difference that transitions this layer from the Precambrian layer into the Cambrian was the beginning of the Cambrian Explosion. This occurred roughly 540 million years ago and was roughly a 13 to 25 million year sequence where complex life began to emerge, evolving from small single cellular organisms of the Precambrian to full-bodied animals that can be found preserved in fossils today, such as arthropods, echinoderms, mollusks, sponges, and more. Prior to this, in the previously mentioned Jacobsville sandstone of the Precambrian, there are no fossil records to be found. Meanwhile, in the following Cambrian layers, there is suddenly an abundance of well-preserved fossils and carbonate sequences, which would have been decomposed layers of smaller organisms from the time. To see this, let's get into the Cambrian sequence. The first major layer of the Cambrian series as it transitions from the Precambrian sandstones is the Mount Simon sandstone. It is a coarse-grained sandstone that stretches to some bedrock layers underneath the southeast areas of the state, which gradually thin out as they approach the northwest corners out to Ontario. It is occasionally interbedded with thin layers of gray and dark red shale. This layer has often been considered as a candidate for the use of CO2 sequestration, or carbon capture uptake storage due to its depth, its ability as a water-bearing reservoir, and interbedded shales, preventing upward migration of CO2. However, due to its depths, few wells have been drilled in Michigan to make use of the layer in such a way. Following the Mount Simon sandstone is the Eau Claire layer, which varies along different portions of the layer and includes a greater variety of rock compared to other layers in the Cambrian series. Divided into three main sections, the lower part is an argillaceous sandstone with some interbedded dolomite. The middle is mostly sandstone with some dolomite inclusions, and the upper part is mostly a sandy, clayey dolomite. Although the layer is named after the town of Eau Claire on the western end of Wisconsin, brachiopod fossils found within cores in both the area and Kalamazoo show correlation and spread of the layer across states. Above this, the Dressbach sandstone, which slowly transitions away from being a dolomitic to a more pure medium quartz grain sandstone. While mostly a regular silicate sandstone in Michigan, some western parts of the outcrop, which stretch well into Wisconsin, have been shown to have been layered with other silicate minerals such as zircon and tourmaline. The last purely Cambrian layer in the series is the Franconia sandstone. named after the town of Franconia, Minnesota, where surface outcrops are found. This layer is mostly a glauconitic and dolomitic sandstone, which has preserved some fossils of ancient marine life during this stage of the Cambrian period. At the very top of the Cambrian layer is the Trempealeau layer, which ends the Cambrian series as it transitions into the Ordovician series. This transition is marked from the sandstone-dominant series of the Cambrian layer to a much more heavy dolomitic layer with minor traces of sandstone and sandy dolomite. This shows a transition in depositional environment of the time, where the oceanic conditions begin to include greater amounts of calcium carbonate, likely from a higher abundance of flourishing marine life. Starting from this layer, many modern wells across Michigan have found pockets of gas, which would have been old remnants of ancient carbonate-heavy sea life such as soft organic tissues. One thing you may have noticed through the video is that many of these layers were named after towns outside of Michigan, primarily in western Wisconsin and Minnesota. This is because, other than what can be seen at pictured rock, Cambrian outcrops are very sparse on the surface of Michigan, and most are studied from drill cores and correlated with outcrops found across Wisconsin and Minnesota, which have an abundance of Cambrian rock at the surface. A general assumption that is made is that the Cambrian series rocks in Michigan do actually correlate with outcrops an entire state away, which are interconnected underground and brought to the surface at the Wisconsin Arch, where the Michigan basin lenses out. Outcrops of similar age, fossils, and compositions as cores found deep under Michigan are compared, which can show correlation of layers. However, though it is likely to be of the same series, it is not 100% confirmed. To recap, the Cambrian layer is mostly composed of a series of sandstone-dominated layers with some inclusions of dolomitic, clay, and shale layers, which would have been a result and signs of remnants of some of the earliest forms of complex life, a result of the Cambrian Explosion of life, marking a new era in geology under Michigan. While most of the layer is buried under many thousands of feet under the state, you can observe some outcrops of Cambrian-age rock on the shores of Lake Superior. If you would like to know more about the geology preceding the Cambrian layer, you can check out our geology series on Precambrian rocks, or if you'd like to know more about the next age of rock, you can check out our video on the Ordovician period.